So our next speaker, we're back on bats, so my subject area is what I'm biased though. So this is Luis Girón. Luis has over 18 years of experience in mammal studies and biodiversity conservation projects in Central America. He's the former coordinator of the bat conservation program in El Salvador, is currently part of the Latin American Special Committee on Bats and Wind Energy and the Bat Specialist Group of IUCN, and president of, I apologize if I pronounce this wrong, Asociación Territorios Vivos El Salvador, or ATVES. And his presentation is called Against the Tide, Recording Insectivorous Bats in Mangroves. I will hand you over to Luis.
Hello, I hope everybody is doing well. Today I have the pleasure to share with you an experience about recording insectivorous bats in mangroves in Costa Rica. Thanks to Wildlife Acoustics for this opportunity, and here we go. Okay, first I'm going to tell you what we did in this little project, what was the purpose, what equipment we use, how we program the settings, how we analyze the data, and a summary of the results. Also, I will share with you some challenges we had and how we managed them. And finally, I will tell you some new ideas. Mangroves are a unique ecosystem. We can find them in all tropical regions. In Central America, we have mangroves on the Pacific coast and the Caribbean coast. One of the characteristics of this ecosystem is that the level of water, because of the tide, changes every 6 hours and 12.5 minutes. In the world, there are more than 1,400 species of bats. In Central America live 148 species. 70 of those are insectivorous bats. Water bodies are important ecosystem for bats, but there are few no-bat species living in mangroves. And what about acoustic data in mangroves? Not much for bats in Central America. The purpose of our study was to know and quantify the species of insectivorous bats in Golfito mangroves, and to compare the activity of these insectivorous bats in this mangroves forest. Our study area was a small mangrove forest in the Pacific coast. In Golfito protected area that is part of OSA conservation area, located on Punta Arenas, southeast of Costa Rica. To collect the data, we use one SM2 bat, known as Richard, in honor to Richard Laval. We use an SMX2 waterproof acoustic microphone with a 3 meters cable, so we can secure the recorder in a safer place. We set the trigger at 12 kHz, and we made 10 seconds WAV files every time a bat activated the trigger. Our study design was as follows. We selected 5 sample sites where we recorded one night per site. The survey started at 5:30 in the afternoon and finished at 5:15 the next morning. Richard turned on every 30 minutes for a period of 15 minutes, so we can measure the activity of bats every half an hour. Everything sounds fine so far, but we had a little challenge. As I told you, the time makes the level of water changes every 6 hours and 12.5 minutes. And for the security of Richard and ourselves, we only could set the equipment when the tide was very low. And in this case, we didn't have a boat available, so going in the high tide wasn't a good idea. So we made a time meter or a tidal gradient, where 1 represents the lowest level of water and 12 represents the highest level of water. This means we have a value for the tide every 30 minutes. Then we checked the tide calendar for the days of the study and made our own tide meter calendar. So if we wanted to start at 5:30 with a tide level of 5 and going higher, we have to set Richard at 3 p.m. But what happens when we want to start at 5:30 with a tide of 6 and going lower? Okay, so 5:30 is our start time. The tide at that time is 6 and going lower. The lowest tide is at 8 in the morning. So Richard must be in position at that time and remove at 9 in the morning the next day. Oh, funny days. But once we crack this up, we could collect all the data. And then the other part of the job, reviewing the files with Kaleidoscope. Personally, I use these FFT settings. With Kaleidoscope, we can count passes of bats that are at least 3 consecutive pulses of the same species. Here, one pass ends with a feeding buzz, and immediately begins a new one. Here we have an example of how to detect 2 species in the same file. At the left, we see 2 passes and a feeding buzz of Peropteris macrotis, and at the right, we can see 1 pass of Sacopteryx bilineata, both species of the family Emballonuridae. For a closer look, here's the spectrogram of Peropteris macrotis. We can see that the second harmonic of each pulse is around 40 kHz, almost in a straight line. And here is the spectrogram of Sacopteryx bilineata, where we can see the pulses by pairs. The first pulse is around 45 kHz and the second a little higher. Of course, talking about the second harmonic of each pulse. Now, a quick review of the results. We identified 21 species of Insectivorous bats in Golfito. 4 taxonomic families represented: Emballonuridae, Mormopidae, Molosidae, and Vespertilionidae. 16 of these species were new records for mangrove forest, and we count 923 passes of these species in 5 nights. With a small sample, we apport new information to the knowledge of the bats in mangroves. The species with more activity or more number of passes was Rogesa bicami, from the family Vespertilionidae. Almost half of the passes counted. It is a common species in acoustic surveys, and it's found in many types of habitats in Central America, often captured in mist nets. The second species with more passes was Rhynchonicteris naso, with 115. This species is from the family Emballonuridae. It is common where there are bodies of water. It is rare to capture in mist net, but it's common to watch in trees near water during the day. Another example of how we can use the acoustic data of insectivorous bats is to compare the activity during the night. In this case, also using the tide meter in the mix. So for the first night, we can graphic the tidal gradient every hour and overlap the activity. The same for the other nights, looking for patterns that give us an idea of why the activity of bat changes during the night. Another patterns we can compare is the activity during the night of related species. For example, 2 Emballonuridae like Rhynchonicteris naso and Centronicteris centralis. Apparently, they have different habits during the night. Or we can compare 2 Vespertilionids like Myotis nigricans and Rogesa bicami. As usual, we end up with more questions than answers. Some of these questions are: how will the result vary throughout the year? What if we compare several mangroves? What about comparing the Pacific coast with the Caribbean? Does the level of water matter for the insectivorous bats? As final thoughts, I can say this. Insectivorous bats are poorly studied in mangroves. But ultrasonic recorders are a powerful tool to collect good data, especially for studying bats in difficult places. I want to thank Wildlife Acoustic for this opportunity, and thanks to the University of Costa Rica for taking me to Golfito, especially to the professors of field biology, to Melissa for her assistance and ideas, and to Bernard for trusting me Richard and his mentoring. Good vibes, everyone, and thank you for your attention.
Thank you, Luis. Yeah, bats in mangroves. I'd never even kind of thought about bats in mangroves. I think of bats in my nice European habitats around here. So not many mangroves where I'm from. We've got questions coming in. So if you're about, Luis, then and you fancy answering some, then we will get some answered. So it is starting off as the excessive humidity and salt air of the region. Has it been affecting your recorder or recordings, such as the microphone? Did you notice any sort of sound loss over time because of this harsh environment?
Yes, it is a harsh environment, and well, in Golfito, in that particular study, just we were there very few days, so we didn't have any problem. But
okay, so it's a short-term deployments, but over like moving them around sort of thing.
Yes, but in another experience here, well, I'm from El Salvador, and that study was in Costa Rica, but in El Salvador, in mangroves also, and was a longer time. And I think that we have problems with the humidity, and the recorders were less good. I think we ended in at the end of the study.
Yeah. So I don't know which microphone you were using, but so I'm in the UK, and nobody thinks of the UK as a humid environment, but it's actually a fluctuating humid environment where you were working, I suppose, in a constant humid environment. So that's having a constant sort of drenching effect on recorders and not being able to dry out. Would you say that kind of fits in with what you were doing?
Sorry, can you repeat, please?
Yeah. So where I'm based in the UK, which is kind of it has a lot of fluctuating levels of humidity. Yours is more of a constant humidity. So it's level, well, but really high.
Yeah, it's really high, and it changes. It depends on if it's rainy season or the dry season. Yeah, it can change a lot.
Yeah. It can change,
but yes.
So there's loads of questions now. How did you deal with insects in your recordings? Were they a big problem? So ultrasonic kind of insects that are going to interfere with your bat recordings?
Yes, actually, there's a lot of recordings that only have insects, so there's a lot of information that we don't use really. So we have a lot of storage that we have to filter the recordings to only analyze the bats. But yes, that's a lot of trouble here we have a lot of insects that activate the trigger. So
Yeah.
we have to figure out how to not use those files.
Could you go into a little bit more detail on how the passes were counted within Kaleidoscope? So
yes, of course. I'm sorry.
No, all
Yes,
yours.
yes. Normally with Kaleidoscope, you can the software automatically can count the pulses, right? But here in my experience, sometimes it miss the actual species that we're trying to identify. So uh, normally we need at least 3 pulses to know which species is. So we use that as a pass, like at least 3 pulses. So if we have in a recorder 3 pulses, we count that as one pass. But if we have like 10 consecutive pulses, that's also one pass. And it it ends if there's a silence or if you have a feeding bus, that is the like a terminal vocalization, like when you know that at least is the bat is trying to feed, like to capture an insect. So that's we counted like the end of the past, the past. So I don't know if if I explained it well, but
No,
that's how we count.
That makes perfect sense. That makes perfect sense. We've got another question, Lewis. Did you do anything special to the song meter or just deploy it as is? Also, was it the newer SM4? Do you think it was, or did you? So basically, did you just put the recorder out as is, or did you put any special protection on it or anything like that?
Well, in Mangroves, yes, we put like a plastic bag, a green plastic bag, protect the, and also we have a cable with the microphone, so we put it was a song meter too, like
Okay.
an old one, in Mangroves. But here we're using SM3 and SM4, but in that particular study we used the SM2, and we protect it with a plastic bag, and we like tangle with something in a tree, and then we put the 3 meters cable to connect to put the microphone away. Like we place the recorder in somewhere safer, not that close to the water, and then we use only the microphone to put to record the bats. That's how we did it.
I like your technical solution of a plastic bag. I like that. We've got. What is the definition of tidal gradient?
Well, that's something I made up. I never I didn't know how to call it. Like, well, no, the tide changed every 6 hours, so I kind of figure out that every half an hour I put a number, and that's how it came up. I came up with that, like a tidal gradient or a tide meter. I don't know how to call it, but
if it works for you, that's fine.
Yeah, yeah.
I think we've got another tidal question here. The graphs showing activity versus tidal level. Sometimes there was a strong correlation, other times the reverse. Any ideas why?
No, actually, that's a good question that could be answered, like doing more studies in mangroves. That's why we came up with more questions than answers. So we don't know. And if you compare each species can be behave very different. So maybe affects a species in some way and another in another way. So there's a lot of things to do in mangroves.
Well, I've got a bit of a batty question for you based on that. The species that you're recording, what's their normal roosting habitat? Are they roosting in the mangroves in sort of cavities within the plants, or are they roosting kind of a distance away? Are they traveling into that location to feed?
Well, maybe some of the species travel a lot of time to get there because the activity started later in the night, and others started immediately when at 5:30. So some of the species maybe roost near the mangroves or in the mangroves, and others came from other places.
And someone's just asked, will you also use cameras in the future in the mangroves?
That would be nice. Actually, I never thought about it, but that would be another thing to do. Yes.
Yeah, well, if in doubt, you just need more equipment. That's all. It's always a good excuse to get more equipment and get out into the field. I quite like that idea.
Yes, I like cameras.
Right. Well, thank you very much, Luis, for that wonderful presentation and answering so many questions. And in a unique, well, what I would see is a very unique habitat to go and chase bats, which is a lovely thing to be doing. Yeah, I can't thank you enough. And I'm sure we're getting rounds of applause, virtual rounds of applause from all over the planet now.